let us study what is gravitation. Gravitation means an attraction. Here we are going to study what is meant by gravitational force. Gravitational force is a universal force which acts on two objects either on the earth or in the universe. This gravitational force first discovered by Sir Isaac Newton. One day when he was sitting under an apple tree, an apple fallen downward. He thought why it is falling downward. Then he concluded that there may be any substance attracting that object towards it. Then he realized that there is earth. That earth attracts that apple towards it. Again he concluded that not the surface of the earth attracting, the attraction is taking place from the center of the earth. Here full earth I didn't draw, only half portion of the earth I drawn, but this is the center of the earth. Then he concluded that each and every object falls downward direction which are close to the surface of the earth or far away from the surface of the object. That is only because of the center of the earth which pulls or attract the different objects towards it. But one more thing he thought that very far away objects like moon, sun, asteroids, meteors, etc. These all are astronomical objects. They are not falling down to the earth. What may be the reason of it? For that again he studied or explained with the different examples. Here now, before reaching to that or before explaining that, we are going to study what is meant by circular motion. Circular motion means the movement of, here I written what is meant by circular motion. Circular motion means the movement of an object in a or through a circular path. For that, two examples we are studying. First example, the movement of moon. The moon revolves around the earth through a circular path. This circular path we are calling as orbit. Other example, here one string is there. Its one end I am holding, other end I am tying one stone or a ball. Then just I am rotating either this way or this way. As and when we rotate this ball, you can find that this ball moves through a circular path. Continuously you can see the movement of the ball. Similarly here also the moon revolves around the earth in a or through a circular path. So such type of movement or motion of the object is known as circular motion. Now we are going to study about other definition, that is what is meant by centripetal force. For studying centripetal force, I am taking these two examples again. First example, movement of the ball through a circular path. Other one, movement of the moon through a circular path. Here, when we people are holding the string and we are rotating the ball, the center or at the center we are there. Human being is there. We are standing at the center and we are rotating the ball. As and when we rotate, what action we people are doing? We are just pulling this object towards us. We are pulling that object towards us. At the same time, this object also tries to come towards us. So as and when we pull the object towards us, at the same time the object tries to come towards us. As a result of it, this object is able to move round and round. At the same time, this object acts or directs towards us or acts a force towards us. This is known as centripetal force. We can call it in other word, that is center seeking force. So we are writing here centripetal force, or we are calling it as center seeking force. Similarly, we are studying about the movement of or the motion of the moon around the earth. Here, how this moon is able to move around the earth. That is, here, this is the center of the earth. This earth or the center of the earth pulling the moon towards it. At the same time, the moon is directing towards the center of the earth. As a result of it, the moon is able to revolve around the earth through a specific orbit. If there is no such pull, then what will happen? Here again I am saying you, here earth or here we are there, we are pulling this object, at the same time this object is directing a force towards the center of or center. As a result of it, this object is moving round and round. Now, while moving it, we are just releasing our hand. We are leaving that string. As a result of it, what will happen? This, where the ball is reaching, from there, this ball will move straight. We can say that with which velocity the ball was moving, with the same velocity, it will move straight. And we can say with which direction it was moving, towards which direction it was moving, through that direction it will move straight. So this is a circular path from which point it moves. This point we can call as tangent. You people already studied in maths what is tangent. So here this is a circular path, then from where this ball is moving, so that point we can say as tangent. Now children, here same thing we can say that if our earth is not pulling this object or pulling the moon towards it, and the moon is not directing force towards the center of the earth, the moon also cannot be able to revolve around the earth. Now we are going to study about what are Kepler's laws. Kepler was a scientist. He prepared or he made 3 laws related to the motion of planets. Here we already know about the motion of the planets. That is also through which one? Not through the circular orbit, through the oval shaped orbit. That oval shaped orbit we are calling as ellipse or elliptical orbit. Now listen here. This is the ellipse or elliptical shaped orbit. Through such orbits, planets are revolving around the sun. When we draw a straight line through the center of this orbit, we are getting a straight line here. Then here at this straight line, here we can say that one focus and here one more focus. So we can say that when we draw, all these are imaginary lines. When we draw a straight line through the center of this orbit, in one of its foci, Sun remains. Sun. Now what I am saying you, suppose if you are taking Earth as the orbit which is revolving around the Sun. It is not necessary Earth, any other planet can be. Now this Earth starts moving from the point A to the point B, and further it will move. Now other point I am considering, here the point is C and here I am writing the point D. Afterwards, here at this point our Earth is reaching. So this point I am writing as E as well as F. Now here I said that two foci are shown. Either Sun remains here or Sun remains here. When the planet moves or starts moving from this point to this point, you can find that the planet is very close to the Sun. At the same time, once the planet reaches to here, it is far from the Sun. Again it is reaching to this region. We can say that the Earth is very far from the Sun. Now, as and when the planet or the Earth or any other planets reaches close to the Sun, the movement of the planet will be very, very fast. At the same time, when it reaches far from the Sun, its movement will be little slow. And very far from the Sun, its movement will be very slow. As a result of it, the area covering by the planet at different positions from the Sun will be same. The central line I am erasing now. With my hand only I am erasing. So here what we are studying, the central point also I am erasing out. So at three different positions I am saying you, here the Earth is there and this Earth started to move from, Earth or any other planet started to move from this point and reached at this particular point. So you can find that the distance covered by this planet is more here. We can say that more distance it is covered here. At the same time, the distance covered at these 2 points, you see, here compared to this, its distance is less. Now once we see here, then compared to this distance and this distance, here the distance covering by the planet will be very less. But one more thing you have to keep in your mind, that the area covering by the planet at this position, and at this position will be equal. Now, third thing, first thing I said you, that is law, later I will explain. So first thing, This is the orbit of the planet. This orbit is an ellipse. Again, at its center, the center of the orbit has two foci. In one of its foci, Sun remains. Second point, when the planet starts moving from one point to from one point to other, or when it revolves around the Sun, we have to consider three different positions. This is the first position, this is the second position, this is the third position. Here you can find that the distance covering by the planet, when it moves from this point to this point, you can find that more distance it covered. At the same time, when it reaches here and we are comparing, or we are starting the movement of the planet from this point to this point, here the distance covering compared to this distance is less. Again, we people are comparing this distance to this, and this distance will be very less. What is the reason of it? Here, attraction between the planet as well as Earth is more, or attraction between planet as well as Sun, not between planet and the Earth, between Earth or planet and the Sun will be more. At the same time, Sun as well as planet here, the attraction between Sun and the planet here in this distance will be less. Here again it will be less. So because of that, the area covering by the planet from in these 2 points and these 2 positions and these 2 points, that means this position and this position, if you are comparing here this distance and the area covering by the planet at this position and area covering by this planet at these 2 points at the same time here, and here these 2 points are there, area covering by the planet between these 2 points, all will be equal. Now, one more thing I am saying you, the square of the period of revolution. Square of the period of revolution we can write as T. Square of the period of revolution around the Sun by the planet, that I am writing as T square, is directly proportional to the cube of the which one? Cube of the distance between planet and the Sun. Cube of the distance between planet and the Sun. But here I am writing cube of the mean distance between Earth or between planet and the Sun. So that I am writing as R cube. So once again I am saying you cube of the mean distance of the planet and the Sun. Now here mean, it's a meaning average distance covering by the planet while it moves from one point to other point. So everywhere means you can see that distance between planet as well as Sun. Here again distance between planet and Sun, distance between planet and Sun. Like that way all the distances, its mean, its average you have to find out. Then its cube. That will be, see here, the square of the period of revolution of the planet around the Sun is directly proportional to the cube of the average or mean distance of the planet to the Sun. Now this we can write in other form also. This in a fractional form if you are writing, we can write, that means this is equal to which one? T square upon R cube. That will be a constant. We can write either t square directly proportional to r cube or t square upon r cube equal to constant. Now here we studied only about the Earth or about any other planet. But we can say that when we study about all other planets, this equation will be correct. Same to same will be there. Whatever planets are there, everyone, for each and every planets, this formula will be same. That is t square directly proportional to r cube. Same value only get, or same thing. Either this way we can write, or we can remove this directly proportionality sign and here we are writing the constant sign. Then we can say that t square upon r cube is constant. Here now proportionality sign is there, but here then equal to became. Now once again I am saying the laws. First law, the orbit of a planet is an ellipse with sun is at its one of the foci, or sun remains its one foci. One of its foci especially we have to say. So once again here the orbit of the planet is an ellipse with the sun at one of its foci. That is the first law. Second law, the line joining the planet to the sun covers equal distances, or equal distances, not distances are different. So we can say once again, the line joining the planet to the sun covers or sweeps equal areas in equal intervals of time. The third law, that is the period of revolution of the planet around the sun, its square, is directly proportional to the cube of the mean distance of the planet to the sun. Will be directly proportional to each other. So once again the third I will say, the period of revolution around the sun, period of revolution of the planet. Now we will study third law of Kepler, that is Kepler's third law. The square of the period of revolution of the planet around the sun is directly proportional to the mean distance of the planet to the sun. Cube of the mean distance of the planet to the sun. So once again three laws we will study. First law, orbit of the planet is an ellipse with sun is one of its foci. Second thing, the line joining the planet to the sun sweeps or covers equal distances, equal areas in equal intervals of time. Third one, the square of the period of revolution around the sun by a planet is directly proportional to the cube of the mean distance of the planet to the sun. Thank you, children.